Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to be looking at partial products and multiplication. Now, in other videos, you've seen me use base 10 materials. This is the 1, the 10, the 100, and I've been using paper versions also. If you want these for your children, these are made out of centimeter grid paper, and I cut 10 by 10s, 1 by 10s, 1 by 1s. I use paper, different colors purposefully to help your children identify the different units quickly, but it's not required. What's helpful with the paper is that I can turn them off. Now, I'll put a link to the multiplication playlist in the description below so you can see the other videos there. They'll go into more detail about some of the examples I'll show for this video on partial products. And before I keep going, just some formalities. If you find this video helpful, please give it a thumbs up. Please subscribe to the channel so that you'll know when other videos are coming. And also share with colleagues and friends, other parents who you think might find this helpful. So with that out of the way, let's look a little bit at partial product multiplication. Now, as I said, in the multiplication playlist, you'll be able to link to other videos that go into a bit more detail about this. I'll briefly show you some of the techniques shown in those other videos, but our focus in this one will be on partial products. Now, I'm going to start with the problem 3 times 28. Now, for this video and for others, I showed you the base 10 materials, and just so you'll know why I'm drawing what I'm drawing, for the 100, I'll tend to have children draw the square. Makes perfect sense, right? For a 10, I tend to have them just draw a line segment. And for a 1, I have them draw a dot. And so that's what I'll be drawing. The reason for that is many children get going very quickly. And if they're drawing rectangular models for each of these, after a while, what they draw for the 1s and what they draw for the 100s looks very similar. It's hard to tell them apart, where this drawing, this set of imagery is much easier. So for this picture, I want to start with just an equal grouping model. So we're going to have 3 groups of 28. Now for this, I don't want to draw 28 dots. That's not going to be very efficient. We want your child to think of 28 as 20 and 8. So I have the 2 10s, and I'm going to have 8 1s. Now, if you notice, I'm organizing these 8 1s. I'm not just going randomly with the 8, because we want to make sure your child quickly looks at this and knows, oh, there's 8 there. This is a 10 frame organization for the dots. We use this beginning in kindergarten and working our way up through the grades. We use it to our advantage for distributive property when we're getting into grades 3, 4, 5. So it's not a model that you use in K1 and then eliminate later. It becomes very helpful as they go up through the grades. Now for this, do you see that I've thought of 28 as 20 put together with 8? It's a very place value look at what we're doing. I'm not thinking of that 2 in the tens place as a 2. I'm thinking of it as 20. And what I have here are 3 20s put together with 3 8s. Okay, so we essentially have 60 and we have 24. Total will be 84. That product is 84. These numbers here, this one and this one, would be called partial products. So if we were to write this vertically, if I'm thinking in terms of partial products, again, instead of thinking of 3 times 8, 4, or we put the 2 up here and do that traditional algorithm, I'll be thinking of the place values for those numbers. So I have 3 8s is 24, and 3 20s is 60. You notice why I said 3 20s is 60. I write the partial products and then find the total. Now, the nice thing with this, and with the distributive property, I can go left to right as easily as right to left because I'm preserving place value and I'm thinking of the parts. So I've got 3/20 is 60, 3/8 is 24. I got the product for each of these places. Those are the partial products, and I find the total. So it's very much a place value look at multiplication, and I'm looking at the partial products, but I hope you see briefly how these partial products link to the distributive property. We're using an algebraic approach to multiplication versus just an arithmetic one. Now let's look at another example. Let's look at 25 times 37. Now, I think you'll agree that drawing 25 circles and putting 37 in each is not efficient at all. So your children, when they get to double-digit multiplication, they'll learn an area model. And think about when you're putting flooring in your house, you might find the square footage for each room, the area of each room, and you can add them together. You can cut up a rectangular area in one room and create a design, and you find the square footage of the design and the remaining square footage, and together that equals the total area. That's what's going on here. It's an additive model, area is, so we can cut it apart and put it back together. Now, again, there's a video on double-digit addition with the area model. You can see more examples, but essentially what we do is we picture this 25 by 37 room, and we use expanded form, place value, thinking of the numbers in terms of place value. What is 25 made up of? It's made up of 20 and 5. See, we've thought of 25 as 20 and 5, and we're going to cut our room, cut our area into two pieces. Now, I apologize, this is not to scale, it's a sketch, but I hope you'll get the idea of what we're doing, okay? How can I think of 37? Well, 37 is made up of 30 and 7. Now, you may see your children do a little bit more where they want to make it 10, 10, 10, and 7, and that's okay. Mathematically, that's perfectly correct, but we're going to keep working with your child to become more and more efficient in the drawings they use in the imagery. So this is how we're thinking about 37. This is how we're thinking about 25, and do you see how I've cut up the pieces? Now, this is helpful because this is now a 20 by 30 rectangle. And if I know 2 times 3 is 6, then I can use that fact knowledge to find 20 times 30. So we have 600 here. And we work with patterns. This is not tricks, it's patterns of what happens when you multiply by tens and powers of 10. I have 27s or 720s, that's 140. I have a 5 by 30 rectangle here, 150. I have a 5 by 7 rectangle. Now again, each of these are our partial products. So when you look at these partial products, how did I think of that 25 by 37? Well, I thought of 25 as 20 and 5, expanded form for 25, but place value, right? And I thought of 37 as 30 and 7. And then that imagery helps us think of the partial products, right? Instead of it being a rule I'm memorizing, I'm kind of picturing these different rectangles. And that's what we're hoping your child gets very comfortable with, is picturing what's going on when they're doing the multiplication. That will help them with story problems later also, when they're doing problem solving. Okay, so what did we have? We had a 20 by 30 put together with a 20 by 7, put together with a 5 by 30, put together with a 5 by 7. And if you remember, when we're adding these, we can do them in any order, and the total will still be the same. Notice also, I'm not using parentheses, order of operations. They aren't required mathematically, but they could be helpful. I could put them in and make it a little more helpful, but not required at this point. So what did we have? We had the product 600. We had 140. We had 150. And we had 35. We get that total, we add them together. So we've got 290, and one of these tens makes 300. So that's 900, right? So we've got 925. 925 should be that total. You can add them up if you want. I have 600 and that 290. That's going to be 890. And you notice how I thought about 35 as 10 and 25? That's the associative property, actually. So I have 900 plus 25, 925. And that's our hope for your child as they're going through all these different strategies, is that they're playful with number, that they can do an awful lot of mental arithmetic. And that comes from not just knowing the facts, those are really important, but understanding the strategies and the related imagery, because this gets us to algebraic approaches. Now, let's look at the same problem, but I'm going to write it vertically. I apologize if you can hear the puppy barking in the background. There must be other folks walking dogs around here, so I do apologize for that, but we'll press forward, eh? Think in terms of place value. You've got 7 5s is 35, and I have 7 20s. Notice how I'm thinking of this as 20, not of 2. I've got 140. I've got 35s or 5 30s. Either way, I've got 150, and I've got 30 20s or a 20 by 30 rectangle. There's my 600. I find the sum of all of these partial products. I end up with that 925. Now again, I can go in other orders with the partial products, and I'll end up with the same total, okay? The same ending product for it. So let's go the other direction. Let's say I have 30 20s. I have 35s or 5 30s. I have 7 20s. And I have 7 5s. You see, addition is commutative. I can do it in any order and I'll get the same total in the end. I can find these partial products in any order. It's just important that I find all of the pieces. And we start here and here to help your child understand what the pieces are that they're multiplying, right? So you'll see them doing the equal grouping. See, it's not that they'll eventually learn that algorithm that we learn, the multiplication algorithm. But a lot of times when they learn that, they really don't want to think about the imagery, but it's the imagery that gets us to the algebra. See, so it's good that they know that algorithm, but we need them to have that imagery that gets them. This is technically binomial multiplication using the distributive property. And then we can link that to the partial products. And the idea is, no matter the order, my product better stay the same. We'll be able to use this also when we get to fraction multiplication, mixed number multiplication. So it's a very useful strategy as we can continue on. I hope this helps a little bit in understanding what partial products are. It's actually just finding the product of those individual places, adding them together, right? Getting that total. The imagery linked to it could be equal grouping. It could be the area model. But again, we can link all of these to that imagery. And then later, let me show you something that might look a little more familiar. I have this 35. I have 7 20s, 140, 170. Okay. Then I've got this. Now, when I was taught it, we shifted over a place, but essentially we're now working in tens, right? So I've got that. You might think of it as 15. I've got 3 times 2 and one more. Now, here's what I'd just like you to take a moment to do. Look at this one and look at that traditional algorithm. How are they the same and how are they different? And that's the same question I would ask your child. Look at those and tell me how they're the same. Do you notice how these two come together to make this one? And these two come together to make that piece. See, those partial products is actually a step. It links to the algebraic property and the step on the way to the traditional algorithm that they can see, oh, well, I can just keep track and do 725s and 3025s and get those totals, and I still will end up with 925. Okay, so I hope this video was helpful. Again, if you found it helpful, give it a thumbs up, subscribe to the channel so that you know when other videos are coming, and please share with other parents or colleagues that you think might find this helpful. And thanks so much for watching.